10 million, right? And my mean, what is my mean? My mean is 98.9, and my standard deviation is 3.72102136.5, which is, again, like I mentioned, the only thing we use in the most thing the thing that we use the most is the normal CDF, which is the normal CDF. We need the lower limit, the upper limit, the mean, and the standard deviation. And the only thing different between 6.4 versus 6.2 is 6.4, you have to find the mean and you have to find the standard deviation on your own. You need to do that conversion, find your mean, find the standard deviation, and then adjust your endpoint, which is once you have this thing here, 0.5428. Question with A. Let's do B, and then see if you guys have question, if you guys right now puzzling up what question to ask. So looking at this thing here, same idea, right? Same information. Now they ask you, find the probability of X less than or equal to 90. So how do we find X is less than or equal to 90? Well, X is less than or equal to 90, which is, again, we sketch our item. And if we sketch our item, this is what we have, which is, again, doesn't matter where your line is, you just put a line here. So where do I shade it? X is less than 90. Do you agree that X is less than 90, which is I have to shade it on this side, right? Which is, this is the side that is smaller than 90. Now, same question go. Do you include the 90? Because of the equal sign, everybody see the difference is if they don't have an equal sign, we exclude them. If we have the equal sign, we include them. So if we include this thing here, if we include the endpoint, which is my endpoint is 90, and I want to include a 90, where should I go? Do I go to the left to include a 90 or to the right? And hopefully you guys see that we have to go to the right because, again, the shaded region is here. I cannot go back to the left, right? I have to go to the right. And if you remember, if you go to the right, you add 0.5, which is now your new endpoint. If you look at this thing here, your new endpoint is basically, again, you're trying to find the area of this region here. We just increase this interval a little bit so that we can include the 90. And to include the 90, we have to go to the right. And if we go to the right, we have to add the 0.5, which is, in this case, what will be my lower limit? Everybody see that my lower limit is some humongous negative number, which is negative at 10 million. My upper limit will be 90.5, right? Negative a million, right? And 90.5, my mean will be 98.9, which is, again, the N times the P. And my standard deviation is 3.72102136.5. And again, once I see my endpoint and my mean and my standard deviation, I plug into here, which is, again, 0.012, which is the probability of X is less than or equal to 90. Okay, meaning I flip this coin, this loaded coin, right? One side heavier than other. I flip this coin 115 times. The probability of the head come out less than or equal to 90 is 0.012. So question here, question on the step, question on the procedure, or question on why I add 0.5 or why I subtract 0.5. Question on the calculator or calculation. So everybody good? All right, let's take a look at C and D. So C and D similar, it's just that instead of ask you either on the left side or on the right side, this thing here, basically they ask you in between, right? So again, we haven't seen the question, which is when we see the question is all the same, which is the next question that you will see. But let's take a look at this thing here. If you were to sketch this thing here, if you were to sketch this thing here, do you agree that, again, this is my normal bell-shaped curve? And because they asked me in between, which is, again, I just draw two lines, which is my 55 here and my 100 here, the bigger number on the right, the smaller number on the left. And because I'm looking for this probability, basically this is what I'm looking for, is the probability in between, right? Again, remember this P is basically find the probability, which is probability that the X is fall between these two numbers, which is, that is what I have, which is inside the middle. Okay, so that's why I want you to sketch it out. Ask yourself, what type of question do they ask me? Do they ask me the left, the right, or between some value? So once we have this thing here, now you have to ask yourself, we cannot use, because we use the approximation, we use this to approximate, we have to adjust the endpoint. And to adjust the endpoint, now you have to ask yourself, do I include the 55 or I exclude the 55, right? Do I include the endpoint or exclude them? Which is, in this case, we exclude both of them, right? Which is, if we exclude both of them, do you agree? Looking at this thing here, I cannot make my item bigger to exclude them, right? I cannot make it this way to exclude them, right? Because if I make it bigger, I include the 55 and include the 100, right? So in order to exclude them, I have to make this item smaller. Everybody see that if I move it inward, I make this item smaller, meaning I exclude the endpoint. So if I move it inward, do you agree that this is what I have to do is, from the 55, I have to move in. From the 100, I have to move in. Which is, from the 55, everybody see that 55, I move to the right. If you move it to the right, remember you need to add the 0.5. From the 100, I move it to the left. And if I move to the left, I need to subtract the 0.5. So that's what you have to remember. If I move it to the right, I add the 0.5. If I move it to the left, I need to subtract the 0.5. So again, everybody see, that's why I have 55.5 as my lower endpoint and 99.5 as my upper endpoint. And again, the mean is the same, 98.9, and the standard deviation is 3.721021365, right? So again, the mean and the standard deviation, once you find it, it's the same for the same problem, okay? And again, looking at this thing here, you know, after this thing here, your calculator will do the calculation for you. So looking at this item, this is what we have in the sense of this calculation. Question in terms of my endpoint, or question in terms of the calculator or calculation. And let's do one more, which is, again, if you look at this thing here, same thing for D, right? You know, and this is, you know, this is one thing is you want to practice sketching. Please practice your sketching. Your graph doesn't have to be nice. You just have to have an idea of what area we're looking for. Because when we get to chapter 7 and chapter 8, they still ask you to sketch this thing here. So practice now, so when we get to 7 and 8, it's easier when it comes to sketching. But looking at this thing here, this is what they ask you, same thing go, right? This is what they asked me is the area between 56 and 110. And again, I just use the same, it doesn't have to be a site, right? I just use the same sketch because again, this one here cannot be the same as that because this one here, the range is only 45. This thing here, the range is 54 already, right? So again, it's have to be bigger, but again, it doesn't have to be that precise. We just need to have an idea. So looking at this thing here, hopefully you guys see that we include the endpoint. We include the endpoint, and again, in order for me to include this endpoint, I have to move my interval to be bigger, right? I have to move my endpoint outward on both sides, go outward so that I increase this range so it includes my endpoint. And if I move it outward, hopefully you guys see, oh, from the 56, I have to move to the left. And from the 110, I have to move it to the right. And again, if you remember that, we move an outward. If we move to the left, what do I do? If I move to the left, I have to subtract 0.5. And if I move to the right, I have to add 0.5. So if you look at this thing here, as you can see, 56 minus 0.5 to give you 55.5, and 110 add 0.5 to give you 110.5. And again, the mean and the standard deviation is the same, which is, again, once you plug this thing in, which is 0.9991, right? Almost include every single item you have, okay? So again, the hardest part of 6.4 is determine your endpoint. You know? So if you can determine your endpoint, then 6.4 is very doable. And in order to make 6.4 very doable, you have to know 6.1, right? Which is the normal, CDF, and inverse norm. Question with this thing here, question with this B, C, or D, how I determine the endpoint and how I got the answer. All right, ladies and gentlemen, if you don't have questions, let's continue. Let's do one more example. Let me erase this thing here. Let me do one more example, and then I will let you guys go. Let's put all of this together. All right. So again, this thing here, the answer, we did it already. I just put it back here. This is the answer for part B, part C, and part D, right? So let's take a look at this thing here. Let's take a look at your problem, right? So again, looking at this thing here, this is your typical 6.4 problem. So big baby, same problem like before, different information, right? So looking at this thing here, they say that the Central Disease Control and Prevention report that 25% of a baby boy between 6 to 8 months old in the United States weigh more than 20 pounds, which is, again, it's the same question before. The only thing different now is the sample of 150 baby is 30, right? And again, keyword you're looking for, approximate. Again, if you remember in 6.1 and 6.2, they don't tell you to approximate. They only tell you to find the probability that find the proportion between 5 something, 5, right? In 6.4 now, they tell you to approximate them. Approximate the probability that more than 40 of the 150 weight more than 20 pounds. Right? So looking at that item, or when you do your homework, or your homework is easy because each section have its own question. So if you click on 6.4, you should have an idea that, oh, this is my 6.4 question. It's the quiz and the test. Is all the problem is showing up and you say, wait, which problem is which, right? So if you see that approximate, that's 6.4. We need to find a mean, we need to find a standard deviation, and we need to find the endpoint. We need to adjust those three before we can approximate this probability, okay? So looking at this thing here, before we do this thing here, we need to know the mean, right? Looking at this thing here, before we can do this, we need to know the mean, which is, hopefully you guys remember that the mean is, we need to take the n times the p, which is, that is my mean, the n times the p. And I need to find my standard deviation. Is the n times the p, give me 1 second. So again, your standard deviation is the n times the p times the 1 minus p, okay? So again, n times p times 1 minus p, which is, again, in this case, we have 150 times 0.25 times 1 minus 0.25, which give me this item here, okay? So again, hopefully you guys know how to use your calculator to find this two number. I don't do the check. If you say, oh, Mr. Tran, why don't I check the n times p and the n minus p? Well, n times p is 37. If you can see this is 37. And if I take 150 minus 37, I will get the other half, which is more than 10, right? So one number is more than 10 is pretty much good to go, right? But anyway, looking at this thing here, once we have this thing here, we need to find, again, for you guys, this is what I want you guys to do, which is we want to sketch this thing, right? Which is, again, do you agree that more than, that's what they ask you, is approximate the probability that is more than 40. More than 40 meaning x have to be bigger than 40, which is more than 40. This is what I have, which is, again, more than 40. My 40 is right here, and I'm looking for the item to the right of 40, right? So how do I adjust this thing here? Remember, it's just more than 40. It's not more 40 or more, right? More than 40 meaning 41 and so on and so forth, which is, I do not include the 40. So how do I not include the 40? Do you agree that I have to move it to the right to not include the 40? And if I move it to the right, hopefully you guys remember, moving to the right, I need to add 0.5, which is hopefully now you can see, sorry. Hopefully you can see that this will be your endpoint, right? Your endpoint is you need to add the 0.5, which is once you add the 0.5, your endpoint will be, again, 40.5, humongous number because we shaded to the right. And again, my mean is 37.5, and my standard deviation is 5.303300859. And again, this should be your answer, right? So again, it's the same idea as the previous problem. The only thing different now is they give you in Word, and it's in Word problem, and then you have to ask yourself, what word do I need to do? Okay. So question with A, probability that more than 40, which is more than 40 is this item. And because I move it to the right, I add 0.5, which is my new endpoint is 40.5, and the rest. Same thing go. This thing here, approximate the probability that 30 or fewer. So reminder, 30 or fewer, 35 or fewer, meaning we include the 35. We include the 35, which is, this is what we have is x is less than or equal to 35. Less than or equal to 35 is the same as 35 or fewer, which is, again, to do this thing here, hopefully you guys see that. Looking at this thing here, 35 is this item here. And because we include the 35, we have to go to the right. And if we go to the right, reminder, we need to add the 0.05, or if you want to, you can go back to our item earlier to see that if we have this criteria, we need to add 0.05, which is now, this is my new item, is this thing here, which is, again, a smaller number because I shaded to the left, my 35, and then again, the mean and the standard deviation, which give me this item here. And lastly, approximate the probability that the number who weigh more than 20 pounds is between 30 and 40. So it exclusive. Reminder, what is the word exclusive mean? Exclusive meaning we do not include them, right? Exclusive meaning, again, the endpoint, we do not include the endpoint. So again, we exclusive the item here, which is, again, hopefully you guys see that there is no equal sign, we do not include them, which is how do we adjust this item, which is hopefully you guys see that this is what we're looking for. We're looking for the in between, which is, again, exclusive. Hopefully you know that from the 30 we have to go to the right, which is we add 0.5, and from the 40 we have to go to the left to make this thing smaller, which is we subtract 0.5, which is my new endpoint is this here, which is at the 30 I need to add 0.5, and at the 40 I need to subtract 0.5, which is my new two endpoint will be 30.5 and 39.5. And again, once you have this, this should be your answer, which is 0.5535. So question with this particular problem here, in terms of how your problem will be looking like, how would it look like?